So I want to make sure that you guys understand. Due during class today is going to be the analysis diagrams, that is 12 and 12 for the sunrise angles, okay, and the sunset angles. These are very easy to do because there's no building involved. All you're doing is you're taking that circle that you had before that was given to you. You're going to draw the lines and then repeatedly offset them, right, in preparation for your design. Okay? So there are 12 for sunrise, 12 for sunset, and then there are 12 for solar noon. Okay? Those are section drawings. You've already been given this stuff. Now you just have to prepare it. You guys will have to have all of those done, okay, and printed to 8.5 by 11 today. All right? Okay. Now, one of the things that I want to bring to your attention, okay, is the idea of sunset in regards to your site. So, I don't know about you guys. I know how I am. If I am working on a site, the very first thing I do, right, when I'm given a site to go look at, is I jump in on Google Earth and I go look at it. If I'm going to visit Colombia and I want to see what Cartagena's like, that's the first thing I do is I go over and I drop myself into the streets and I walk around Cartagena. If I want to see, Paris, then I'll go over there and take a look because Google Earth will let you do that stuff. So it makes perfect sense that you might try that with your particular site. And here is your site. It's right beneath the Edris house. Okay? In Palm Springs. That's the Edris house up there. Your site's right here. So if you were to drop yourself onto that street and you were to look around, you're going to see all this ugly, hideous Google Earth stuff until it clears up. Right? You're going to note that you have a magnificent view out towards the desert floor from your site. Okay? So like that, looks like you're in an airliner. It's like all lit up. All right? You've got mountains and rocks all around you. Okay? But one thing that's kind of important to note is that these mountains right here, and this will tell you what direction you're facing. Right? So right there we're facing west. All right? So at the equinox, these mountains are going to block the sun at an earlier time than sunset. All right? And part of what it becomes your job to figure out, okay, how much before sunset is that going to create an early sunset where I'm not getting any direct sun rays. Now, remember that the sun sets north of west, so it sets out that way. Okay? And it becomes important for you guys to note that, hey, you know what? The sun in the summertime is going to set earlier or later, right, than it does in the spring, which is there, and in the fall, which is there. Or not the fall, I'm sorry, in the winter. So you know how this is directly west, right there, from your site, right? And you know that the sun at the equinox sets directly west, right? And you would think that they would know that, but they're all looking at me like, I'm not sure. Doesn't that depend on where you are? Well, it depends on which hemisphere you're in, but yeah, the sun always sets to the west at the equinox, exactly west. You guys should know that, but I'm not clear that you guys do. So in either case, that's sunset, looking that way. So part of what you might need to figure out is, okay, well, how early is the sun going to set? Give it an estimate. I'm sorry, there was a comment made. I am recording. Okay, so the sun sets north of west, right? And so there's no mountain there, is there? No. So the sun is going to go all the way down to the approximate horizon And in the summertime, you're going to get full-on sun. Going back this direction, the sun sets south of west. And so in the wintertime, it's going to set pretty early because that mountain is so close, right, that the sun sets behind it in the winter. Looking off to the east, there's really no effect because that is exactly east right there, right? And you can see, literally see the horizon out there. So east of west, south of east, not really in effect, and north of east, not in effect. So for those vector lines, right, they're going to completely impact your analysis. This is directly related to the notion of contextualized site analysis. So in Claremont, you were thrown a curveball. I put a bunch of big old giant trees so that they would block a part of the site, right? And of course, 80% of you put your building in that shadow. And then you turned around and said, yep, I'm planning to use passive solar. Right? Doesn't work. So you had to move your, well, some of you didn't, moved your building back out of the shadow of the trees. Okay? Palm Springs is a very different climate. So in Palm Springs, you're not going to need a lot of passive heating. Maybe a little tiny bit, right? But for the most part, in Palm Springs, if you insulate your house really, really well, okay, you can get by with almost no heat. A little bit of passive heating, and you don't need heat in Palm Springs. There's houses, a lot of houses were built back in the 50s in Palm Springs that don't even have a heater. Okay? So, any questions about that? So, part of what I was doing just now, right, was taking a look at how tall this ridge is to the west in relationship to your site. Your site is about right here, right at the foot of that mountain. Okay? So if you go into Google Maps and you toggle on topography, terrain, right, you'll get this map right here. And you can pretty much tell exactly where your site is. Your site's at about, 750 feet of elevation. Let's call it 775. And within a very short distance is a 1,600 square foot ridge. Right? So that distance from your house to that ridge, not very far, and that ridge is about 1,600 feet or 1,400 feet high. Going all the way over to the mountain range, right, the average height of the mountain range is somewhere about 8,000 feet. Okay? So to that ridge line right there, it's about 8,000. Actually, to the ridge line is more like 10,000, but you're not going to see the ridge line because there's other stuff that's higher closer. All right? So if we go back to this thing here and we exit Street View, set north back up. So to the west, if I measure it in feet from my site, the ridge is about 60,000 feet away. Okay? To the west. So write these numbers down unless you want to look this up. So 60,000 feet straight west of your site is the ridge line approximately. And it is 8,000 feet high. So pretty much from your site, all you've got to do is draw a line, right, in one direction, 60,000 feet, and then draw a line 8,000 feet up, and that'll give you the approximate angle of where the sun's going to set on the equinox. Okay? In the summer, forget it. You're going to get sun because the sun The sunset angle is somewhere over in here. Okay? But as you come around here, right, it's going to get blocked. Okay? Any questions about that? Okay, so your assignment right now during class is going to be to sit at a computer and build those drawings that you were given before, number one. Number two, you will find out what climate zone Palm Springs is in. Okay? You will find the PG&E climate zone stuff for that, and you will print it out in color, okay, for use in your binder. You will also print Weather Spark in color, presentation quality, to put in your binder. And you will print the climate consultant stuff in color to use in your binder. Okay? Any questions? All right, so that's what you're working on during class. While you are doing that, Hiro and I are going to be coming around to our respective students, right, and taking a look at your homework. Okay, for your homework, you were to do an analysis of your existing terrain, and you were to create between 5 and 10 pads 3 feet apart. And you were to show balanced cut and fill. Okay? So, that's it.